Today we are going to focus on variation. Another topic, a different topic. We are now on topic 5, guys. And I really hope you are getting it and understanding. As I've seen lately, it's the basis. I'm focusing on the basis of O-level mathematics. So if you follow my videos, trust me, if you follow what I give you, I'm going to make sure that at the end of these topics, because you're covering all the topics from form 1 to form 4, all the topics, all the questions, we are covering them in this video, in all the other videos that I had posted earlier. Okay, so I was saying that I would like to, when I finish this course, all these topics, right, I'm going to start doing question papers. So we start with question papers, and where you don't understand a topic that you do not understand, you have to remember that I would have given you the base already. So you just go and revise and see where you're not getting it as you would be doing the question papers. And please, guys, forward the link so that we can help each other. Also, just not about mathematics only. Mathematics is there for us to be able to know that for every situation that we might face, there's always a way out or a solution to that. So as we do mathematics, just open your mind to that level. There is always a way. Maybe I'm not just finding it yet, or maybe I'm not understanding all the concepts yet, but there is always a way. Even in our lives, there is always a way out for every situation. Okay, so on variation, as I've said, we're focusing on variation today. So on variation, we've got 3 types of variation that we're going to focus on. And the first one is called direct variation. After direct variation, we've got inverse variation. After inverse variation, we have joint variation. Okay, so of these, we are going to start with direct variation. Okay, this is a form 4 topic. So I would like you to really understand. Okay, so on direct variation, what is happening is from the word, it says direct, right? So for examples that involve direct variation, we have got like maybe the distance traveled is directly proportional to the time taken. You know that formula, right? The distance traveled is directly proportional to the time taken. Okay, so for that one, it will be like you write as distance. Alright, I'm saying distance traveled is directly proportional to the time taken. This is an example of a direct variation. Okay, so if we have to simplify this into mathematical terms, it would become D is varied to is proportional to T, the time. D is proportional to T. So I've now simplified this whole statement to just D is proportional to T. Okay? So this is how it's done mathematically. But if we have to draw a graph of this, it would be a graph. Here is my D, and here is my T. Okay, so to draw the graph, it would be like it's directly proportional. So D is directly proportional to T. This would be the graph for direct variation. Okay, going to our second part is, as I said, we are going to talk about what's this called? Inverse variation. Okay, so what are we saying on inverse variation? I can give an example of maybe we say the number of people who take tea from a pot. The number of people who take tea from a pot is inversely proportional to the number. To the amount of tea in the pot. The number of people who take tea from a pot is inversely proportional to the amount of tea in the pot. Okay, what am I saying? Is we know if the number of people who are drawing tea from a pot increases, it means that the tea is lessening, right? That's just how it is. As the number increases, the amount reduces. Okay, so I'm going to say number. Let me simplify my number. Number of people drawing tea from a pot is inversely proportional to the amount of tea in a pot. Okay, so what would be the mathematical formula for the inverse variable according to this our sum? Let's say the tea in the pot, we refer to it as the volume, is inversely proportional to the number of people. Like this. The volume is inversely proportional to the number of people. Meaning that as the number of people increases, right? As the number of people who are drawing tea from the pot increases, it lessens. If you put 2 here, if they are just 2, it's still okay. 3, 4, 5, 6, 7, 8 at the bottom. It's lessening, okay? So that's how it is. Now the graph for this part would be the inversely proportional. So we have our V here with our 1 over N here. And our V is inversely proportional to N. So this is how it's gonna be. No, here it's not 1 over N, it's just N. You just put N here. Okay. So this would be the graph for direct for inverse variation. Okay, now the last point, the last part is okay, so for joint variation, what we are saying is the mass M of a coin of radius R and thickness H depends on the volume V of a metal coin. Let me write it down. The mass M of a coin with radius with radius r, thickness h, depends on the volume, it depends on the volume V of the metal in the coin, of metal in the coin. Okay, as you can see, this is now joint variation. The example is the mass m of a coin with the radius r, thickness h depends on. Whenever, even if you are not told, as long as they say it comes with this form and they were explaining the radius, the height, just to know. As long as it comes in this form, saying mass m of a coin with the radius r, thickness, I just don't know how to explain this, but this is just how you see it. That's how it's different. As you can see from the other that we are just dealing with just one thing. It's just volume and the number of people, or what was the first one? Distance and time. But for this one, it's mass and radius involved, height involved, volume involved, everything. Okay, we know that volume of a coin is V is equal to pi r squared height. Okay, this would be the volume of which we are saying m is let me use another point. We are saying m is proportional to V. We are saying m is proportional to V, right? So if m is proportional to V, we also know that m is proportional to pi r squared height. And since pi is a constant, we can also write this as pi m is proportional to r squared, brackets where pi is a constant. Okay, so this is how it's gonna be. Okay, now for our first example, let me just put example here. For our question 1, it reads, if x is proportional to y and x is 5 when y is 4, find x when y is equal to 6. For this situation, we know that this is direct variation. Okay, so I'm going to say solution is equal to x is proportional to y. X is proportional to y. So for us to remove x is proportional to y, to put the equal signs, we are going to say x is equal to ky. Okay, so for you to remove the proportional sign, you replace with a constant k and a y. The y is already there. You replace with a constant k. Don't forget that, okay? So this is how it's gonna be. But now, as you can see, for the first part, we are given the variables. X is equal to 5 when y is equal to 4. So these variables enables us to calculate for k, to know the value of the constant k. So we substitute. Okay, we substitute this part. It's gonna be x is equal to 5 is equal to k, y is equal to 4. Okay, so we divide here to obtain k. So here k is equals to 5 over 4. I will not simplify it further. What I'm going to do is now answer our question. As every variable is now known, we now have to answer the question. The question reads, find x when y is equal to 6. Okay, so we know that x is equal to k, y, and we also know that x is equal to 5 over 4. This is replacing k, y. Here we substituted. And also we are given that x is no unknown and y is known. So x is equal to 5 over 4. Because we also substituted this part. Okay. Now to simplify this, we know it's gonna give us 2 here, 2, 3. This will give us 15 over 2. That is equals to x is equals to 7.5. So this is how it's done. Okay, ladies and gentlemen, this is another question, but this one involves inverse variation. Okay, I'm just showing you how it's done. So for this part solution, given that f is proportional to v, f is proportional to v squared over r, and that f is 50 when v is 5 and r is 2. We are going to start with the first part, right? So first we are supposed to remove the proportional sign. So it's 2b. It will end up as f is equal to, we put a constant k is v squared over r. Never forget to put a constant. Okay, now that we have put a constant, we have to determine the value of the constant that we have put, okay? So we are going to say, we are given that f is 50, is equal to 50, k, we do not know who he is, 5 squared over r is 2, okay? So we simplify, this will give us 100. This goes to 25k. We simplify, we know that k is equal to 4. Okay. So now that we know that k is equal to 4, we now have to answer the question. Find the value of f when v is equal to 9 and r is equal to 6. Okay. So we are going to say, we know that, let me write this part. We know that f is equal to k v squared over r, and we are also given that 50 here. Okay, now we simplify. Okay, so for my final example with you guys for today on variation, it reads the kinetic energy E joules of a moving object varies jointly as the mass making of the object and the square of its velocity. As you can see, it's joint variation. Okay, so the first part reads write down an equation connecting EMV and constant EMV and A and constant K. Okay, so what you have to do is, as long as you are still in ordinary level, you have to know these things. You have to know this kind of formulas, because if you do not know the formula, I'm not sure if you would be given, but if you do not know the formula, this one you cannot tackle it. So you need to know the formulas, and you have to know them by head, so that you know because as long as you do not know whether it's part A or B or C, you can't even do anything about it if you do not know the formula. Okay, so know the formulas. Okay, so for part A, the formula would be the formula would be E is proportional to mv squared. Okay, that's the formula for kinetic energy. And replacing it with the constant k is going to be E is equal to k mv squared. I think we have dealt with the constant. We now know what the constant is and its value on an equation. So that would be for our part A. And our part B is, we are given that E is 150 joules when the mass of the object m is equal to 12 kgs and the velocity v 5 meters per second. Find the value of k. So first you have to find the value of k. What are we given? We are given E as 150 joules. We are also given m as 12 kgs. We are also given v as 5 meters per second. Okay, so we now calculate for k is equal to E kmv squared. We substitute 150 km12 v5 squared. Do not forget the squared, okay? And we simplify. Here it's k12 is 25. If you simplify that part, what do we get? We get 300. No, 300 k over 150. We simplify. So it's gonna be a half. Okay, so k is equal to a half. Then the part C reads, calculate now the kinetic energy of an object of mass 24 kg, which is moving with a velocity of 7 meters per second. Okay, so since we now know what k is, it will be very easy for us to simplify this equation. We are looking for the kinetic energy, given that the mass, we know that k is